Hello students. In this video, we'll be discussing solutions for April 2021 CM1 paper B. Hope all of you are doing safe and healthy. It's very important to stay home. Please stay at home now. Yeah, so this paper was quite an easy paper, which has come this term out of all the previous terms of CM1, whatever paper has come. This is the easiest paper which has come. Very straightforward, very direct. So let's see, starting with question 1. Mortality tables of males and females are given in question 1 base worksheet. Calculate the probability for a male life aged 25 exact and a female life aged 21 exact that both lives are still alive on the date of female 60th birthday. Both lives have died before the date of female 60th birthday, and female has died before age 60 exact, and the male life is still alive at the end of year of the female's death. So first things first. So this is the dates, mortality rates which have been provided. Now we have been told to calculate both lives are still alive on the date of the female 60th birthday. So we need to calculate. So this is there, the male age X, QX is already, this is the same mortality table from there. Now if we have the age of male and we have the age of female, the male age is 25. And so PX is nothing but 1 minus C11, which you can see is this is the mortality rate, death of rate. So this is the death survival rate, and similarly for females the survival rate. Now we'll have to calculate it using the consistency principle, so that they live for probability of staying alive over the years. Okay, so first at time start when they've bought the policy, when they're in the policy, then that time the probability is 1. Next state is 1 into PX, then becomes PX into PX plus 1, and so on. Okay, then similarly for females also, and for joint lives, so saying both of them alive, it is PX into PY. So the last probability which we get for both PX into PY is equal to 0.841804. That is at the age of 60, female's birthday. Okay, 0.0804180. So nothing was just multiplying TPX into TPY. Next, they said both lives have died before the date of female's birthday. So this is nothing but last survivor. So last survivor is nothing but 1 minus PX plus PY minus PXY. So this is the PX plus PY minus PXY, and the last probability is 0.010574. And required probability for the female died before age 60, but the male is still alive. So 1 minus the female's probability of living into the male's probability. 1 minus, basically 1 minus PY into 1 minus TPY into TPX. So that is what it is giving us. Okay, so 0.0839301. This is the first question. So direct, 14 marks, anybody can score. No, there's no pardon. And I again, same for Excel, it may be that there are 2 marks for some column, there may be 3 marks for some column. According to me, if the first part should carry the most marks, so the first part may be of 7 marks, and the remaining parts may be divided as 3.5 and 3.5. Not sure of how they will have divided the marks, but maybe that is the case, that each column will fetch you some marks. Okay, even if like if I see 2, 4, 6, 8, 10, 12, 14. So maybe 7 columns fetching you 2 marks each can give you these answers. Okay. This were the final answers. For question 2, coming to the question 2 base worksheet contains the data from 20 different banks labeled A to T. For each bank, you are given the effective annual yield available on income-bearing investments of different terms ranging from 1 to 10 years. Calculate the 10-year par yield offered by each bank. Again, very direct. So this was the base annual effective yield rates given to us, and we needed to calculate the par yield. So par yield is nothing but the yield in the final year, which is 1 minus this divided by the sum of the yields of all the years. So this is the par yield of the 10-year par yield for each of the banks. Determine which bank offers the highest interest rate. Next is determine which bank offers the highest 1-year forward rate at time 3 years. So 1-year forward rate at time 3 years is, we'll take all the interest rates. So base all the 1 plus I to the power 4 divided by 1 plus I to the power 3 minus 1. So we've taken all to forward 4 years divided by 3 years minus 1. So we get the 1 year forward rate at time 3. Okay, and then you take a maximum of this so that you get the maximum 1 year forward rate by which bank. Similarly, for 2 year forward rate, you take it to time 8 and divided by time 6 to the power half, because it is 2 year, so it becomes biennial. And in case of biennial, we take to the power half minus 1. So this gives us the 2 year forward rate. Okay, at time 6 years. Since we wanted it at time 6 years, so from 6 year 2 year forward is 8. So 1 plus 2 to the power 8 divided by 1 plus 2 to the power 6 minus 1. So this is the time starting at time 6 years. Okay, and again take a maximum of this, so get the best interest rate. Next question 2 part 3 was, an investor would like to purchase a 10-year increasing annuity certain payable annually in arrears from one of the banks. The first annuity made at the end of the first year will be 1,000. Subsequent payments will increase by a fixed amount of 500 each year. Determine which bank would provide the cost at lowest cost, which provide the annuity at lowest cost. So this is a thousands annuity, which is increasing by 500 each year till time 10, and we have already the calculated spot rates over here. 1 plus I, this is the spot rates of each year. So 1 plus I to 1 plus base to the power minus time. This is gives you the present value of coupon. And the par yield. So when you come here, this is nothing but C9 into the value there. Question 211, whatever present value we had calculated, that is the discounting factor basically. So you multiply with the discounting factor. This is all the present value, and then the sum of this will give you the cost of annuity for each bank, and then the minimum will give you the this. Okay, now they have asked you determine which bank would provide the annuity at the lowest cost. So if you see 28669.71 0.71 is this bank, which is bank K would provide you. So you have to write bank K would provide you the one with the lowest cost. Similarly, this also, which bank offers the highest 1 year and 2 year. Here also you have to mention in part 2 also which bank is providing the minimum and maximum. Okay, so it's 0.157456. You can just highlight using, if you use conditional formatting, you can just highlight the values. So if I say new rule, and in this new rule, format only cells at cell value. Just need the minimum cell value. Sorry, format only top or bottom rank values. You can just check. You need the maximum here. So top, and you can just do 1. Set format to any color you want. So if I do fill here, say I'm doing a fill of very light color, beige, say, and apply. So you see 0.15 cents, the bank I provides, and just do the same thing here as well. Conditional formatting, new rule, format only cells and top or bottom, and format beige color. Okay, so if you do, so this is the bank which provides, bank L, which provides the one at the lowest rate. Similarly, in this also you can use the conditional formatting, so that it's easier for you to understand, and it's a question, it satisfies the question basically, that which bank provides the one at the, here it's the, let me go back, cancel once. Here it's the bottom now, not the top. It has to be bottom, and just selecting the same color. So it's this bank. Okay, bank K. This is the one which provides at the lowest rate. Coming to question 2 part 4, calculate the effective annual rate of return achieved by the investor on purchasing the annuity from the bank as determined in part 3. So you have to calculate the annual effective return achieved by the investor on purchasing the annuity from the bank as determined in part 3. So in part 3, whatever minimum value we have got, we have to equate it over here with the annual effective. So let's assume an interest rate of say 5%. Once you assume you know the payment of the annuities, you know the discounting factor 1 plus I to the power minus time from this, and now you have to set this cost of the annuity to the one in the previous sheet, which you have calculated. So this difference should be 0. So you can just go to data tab, what if analysis, goal 6, set value to 0, and changing cell should be my this value. Okay, so this should be 1.89%. And then the last part is calculate duration of the annuity. It's very simple. Duration formula is T CT into V to the power T divided by CT V to the power T, which is the present value. So first you calculate T into CT into V to the power T, which is 1 plus I to the power minus of time. Okay. T CT V to the power T, and then here it is CT V to the power T, and then sum of these two, and then division. So duration is 6.64. Okay, you can just, I'll just zoom in here for you all to see. For zooming in, so please see, this is T into CT into V with 1 plus I, which is in the part D4, what we have calculated, to the power minus of time, which is here. And we have dragged down the formula, taken a sum over here, and then again CTV to the power T, dragged down, taken a sum over here, and duration answer is this. Okay. And you can just take a summary of your answers. This was a 50 marks, 50 marks, 50% of the paper has been done, 47 marks has been done. Now comes the question 3, which is of the maximum marks of 53 marks. It's a profit testing question, but very direct. A life insurance company issues a 20-year without profit endowment assurance to lives aged 40 exact. The sum of assured includes 100,000 will be paid if the policyholder dies during the term of the policy or of the survival to the end of the policy term. The death benefit is payable at the end of the policy year of death. Surrender of the policy is permitted at any time during the year. The surrender value is equal to the net premium reserve held at the beginning of the policy year and is paid immediately on surrender. So surrender value is paid only and immediately on surrender. Premiums of 4,000 are payable in advance throughout the term of the policy year. The company will hold net premium reserves. The valuation basis is given in the question 3 valuation basis worksheet. Determine the net premium reserve. So let's see the data which is given to us. So this is the valuation worksheet. If you say mortality is given and voluntary mortality says 80% of this table, there's no surrenders in the net premium reserve, and valuation interest rate will be 5% per annum. Okay, so basically reserves will be maintained at this interest rate. Now coming to first question 3 part 1, let's see what we have done. So for question 3 part 1, a sum assured is of 100,000. So policy year goes from 1 to 20, as you know, age goes from 40 to 59. Base mortality is from the valuation worksheet. Now, what valuation mortality is 80% of the base mortality. 1 minus QX will give us PX. TPX is nothing but first it is 1, then it starts from this into the original probability. Then we have a discounting factor. So if you go to PX, you can see all of this is there. We have our TPX, same formula. Then our discounting factor is nothing but 1 plus valuation interest rate 5% to the power time minus 1. Okay, minus of time minus 1 because you're discounting. This is discount rate. EPV is nothing but TPX into discounting factor, and then annuity in annuity advance formula is sum of this divided by EPV. As we know, this is the annuity advance A due formula. And then net premium reserve is nothing but annuity in advance into 1 minus J9, which is sum assured into 1 minus J9, which is going constant, divided by which is not fixed but divided by fixed. If you remember this formula of the net premium reserves approximation, which we follow in theory as well, this is the same formula, S into 1 minus A due xn, x plus 1 is to n minus 1 divided by A due xn. So this is that formula if you follow. And then, so the first, at starting there is no reserve, but at the end there is 92,776 reserves. Okay, matched, and you know you're working correct if your EPV of an endowment assurance or EPV of an annuity comes 1 at last. Okay, so this is correct. Then moving on, All assumptions used to perform the profit test of the policy as contained in the question 3 profit test basis worksheet. So let's see what they've given over here. They've given the QX, which is now the mortality rates to be used for profit testing. They've been given the independent rates of surrender for policy year 1, 2, from 3 to 19 and 0% in the last year. We know we cannot surrender in the last year. Assumed independent mortality rates is 90% of this cycle. This is also not 90% of this. Initial expense 500, renewal 50, 75 initial commission, renewal 5% of the premiums, effective interest rate 4%, claim expense 25, and a risk discount rate, please make sure it is 10%. Okay. So coming to question 3, part 2, they've told us to calculate the dependent rates of mortality and surrender. Dependent rates of mortality. So we have to calculate AQXD, AQXS. So first revised QXD is nothing but 90% of the profit test, the mortality rates which we have been given in this sheet. Then QX surrender is nothing but we have been whatever we have been given is at age year 1 it is 0.1, 41 it is 5%, 10%, 5%, and remaining year it is 21. Last year it is 0. Mu XD we know is nothing but minus of ln of 1 minus QXD. Mu XS is again the same, and AQXD is nothing but the formula which we know, mu XD divided by mu XD plus mu XS into 1 minus e to the power mu XD and mu XS. And same for AQXS as well. So this calculates the dependent rates of mortality and surrender for us. Okay. Very direct. Last, the profit margin of the policy. The maximum marks which part contains lot of formula is needed. So a premium of 4,000 is being paid, sum assured of 100,000 is there, claim expenses of 25, initial expense has been given to us as 500, renewal expense is given to us as 50, initial commission is 3,000, 75% of the premium. Renewal expense is again, I think I remember 5% of the premiums. So this is 5%. Then interest rates is nothing but premium minus expenses into I, which is 4%, I think. Yes, effective interest rate is 4%. And AQXD we have been given, we have calculated already. AQXS we have calculated already. APX we know is 1 minus AQXD and 1 minus AQXS. No change. Death payments is no, sum assured is 100,000. Maturity payment is also same. Death and maturity claim expense is also same as given in the question 25 in the profit test basis. Surrender payment is something equal to the net premium reserve calculated in part 1. Surrender claim expense is again 25 for all claim expense they have said. So expected death claim expense, death cost plus claim expense will be nothing but death payment plus claim expense into the mortality rate, and maturity will be same, death cost plus this into maturity rate. Surrender cost will be same, surrender cost plus claim expense into mortality rate into 1 plus I to the power 0.5 because it is payable immediately on surrender. Okay, payable immediately. Surrender is payable immediately. Whenever it's payable immediately, we do 1 plus I to the power 0.5 till 1. And last, it will not be 1 plus I to the power 0.5, but it's 0. So it doesn't matter. Since it's 0 in the last, it will be nothing over here. Okay. Now expected cash flows. Coming to expected cash flows is nothing but initial premium minus expenses, all the expenses, premium minus all the expenses, commission plus the interest minus all the death cost and maturity cost and surrender cost. Opening reserves is, as we know, we've calculated as the surrender payment, whatever we've calculated in first part. Closing reserves is whatever we are. No cost of increasing reserves is CIR is equals to closing reserves into 1 plus I minus opening reserves into APX. Okay, and profit vector is equal to expected cash flows plus the cost of increasing reserves. Okay, once this is there, then you have calculate the profit signature. You need probability of staying in force over the year. So first is 1, then is 1 into APX, and the last Profit signature is equals to Z10 profit vector into probability of staying in force. Discounting factor is 1 plus risk discount rate to the power minus of time. NPV is profit signature into discounting factor, and sum of this is a total NPV. Now we need to calculate EPV of premiums. For that, we need to calculate risk 1 plus risk discount rate to the power time minus 1 because premiums are payable in advance. And EPV of premiums is nothing but APX into probability of staying in force into discounting factor into the premium pay. Sum of this and profit margin is nothing but sum of the EPV of premiums divided by NPV. Sorry, NPV divided by EPV of premiums. NPV divided by EPV of premiums gives me the profit margin. This is it about the paper. There was no comments in the paper for the first time. It was very, very direct, only calculations in CM1 paper B. A very direct paper to be solved for the students. Thank you.